How's it going, everybody? So today we're going to be talking about inverse of a function. And so what we're going to be doing is we're going to take certain functions and we're going to end up switching the y and the x, okay? And we're going to then solve for y once again and then be able to determine the inverse of the original function. Now, that's kind of a general explanation of it. Now, the way we can tell that it's an inverse, okay, is that the inverse of a function is a reflection, okay, of the original function. And where you typically find this reflection is you find it along this line y equals x, okay? And you'll kind of see where that comes into play in just a moment when we start solving for these different functions. So, for example, let's go ahead and do y is equal to 2x plus 3, okay? Now, I originally said what we're going to end up doing is we're going to end up switching the x and the y. And so, literally, x and y are now going to flip, okay? Now, the next thing is we're going to solve for y, okay? So that means I want to get y by itself again, so I'm going to have to subtract 3. I'll subtract 3 over here, so I've got x minus 3 is equal to 2y. And then I'll divide by 2. Now, when you divide by 2, you got to do it to the entirety of x minus 3. And so then you have yourself a x minus 3 over 2 is equal to y. Now, some of you may not like the way that's written. That's okay. You can rewrite it as y equals x minus 3 over 2 if the way that's written is bothering you. So this right here, okay, is the inverse of our original function, okay? And we said that we could see it reflected about the y equals x axis, okay? And that y equals x axis is right here, okay? That's y equals x, okay? And these graphs in particular, okay, and I'll see if I can graph this one with blue. And then I'll graph this one with, let's do green. Okay, the inverse will be in green. So, since I have green going, we'll go ahead and we'll sketch the inverse. And so the inverse would look something along the lines of this. If you were to kind of, do a rough sketch, it would look like that. And then the one that's the original, okay, would look something like this. Oh, let me back up. There we go. It looks something like that, okay? Because basically what I did is this is 3 up here. That's plus 3, and then you go basically up 2 over 1. And that's kind of how it would look for the original function. Now, how do we still, though, that kind of doesn't explain how y equals x comes about. Like, why is that still the reflection point, or the reflection line for these, the original function and the inverse? Okay, well, let me go ahead and show you that. So let me pause this and I'll erase this and show you how we get to that. All right, there we go. So the way we get to that is we can actually do this thing called composition of functions, where I can take f of x. Now, we talked about operations of functions in the last video where we added them, we multiplied them, we divided them, we subtracted them. But here I'm composing them. Now what that means is I now have my f of x, okay, alright, is going to go inside of g of x. Or you could say it the other way, that like g of x is going to go inside of f of x, okay? That's how I'm going to compose them. Now, I think out of the two that I just suggested, I think this one would be the easier one to see first, okay? So let me go ahead and show you that one. So if I'm going to put g of x inside of f of x, the way we write that in notation is we say f of g of x. Now, you're looking at that going, well, what does that mean? Well, that means wherever we see an x for the function f of x, we're going to replace it with the function g of x. So just to kind of remind you, the function f of x how it looked without the g of x inside of it, was 2x plus 3. But if I'm going to put g of x inside of it, that means I now have that x minus 3 over 2. And I'll go ahead and I'll try to keep that a different color. G of x, and that was x minus 3 over 2. Okay, so looking at this right here, and I'm going to be flipping back and forth, we have 2. Now, like I said, I'm going to start plugging in wherever I see an x. I'm going to now put the function g of x, and so I have x minus 3 over 2, and then plus 3. So notice, what is in red, that's still that f of x function, and what is in blue is what I'm plugging into that function. Now, looking at this right here, we then go ahead and solve, okay? We try to simplify. Now, something right off the bat, hopefully you can see, is these 2's, 2, you know, if you're multiplying by 2 or dividing by 2, well, that simplifies to 1. Then, if you were to do this, you'd have f of g of x is equal to x minus 3 plus 3. Well, what are the 3's going to do? They're going to simplify out. And so you have f of g of x is equal to x. Well, we just got done saying that these, the original function and the inverse function are a reflection of each other about the y equals x line. Well, that's what this is right here. This is that y equals x, okay? Because the idea is that the original function and the inverse function simplify each other down into the line y equals x, okay? That's the idea. Now, you can do it the other way, though. So let me pause this and show you the opposite way. Alrighty, so I went ahead, I kept the equations color-coded. So now what I'm going to go ahead and do is I'm going to take g of x, okay? Now I'm going to place f of x inside, okay? And so with g of x, you know, having f of x, wherever I see an x in the function g of x, it's now going to be replaced with the 2x plus 3. So currently what I have right now is I have my, I'll put it in red, 2x plus 3, okay, and then my plus, or no, sorry, not plus, minus 3 over 2, okay? So with that being said, we start to simplify. Well, these up here on top, the plus 3 and the minus 3, those are going to add to 0, so those will go ahead and simplify. And so then you're left with your g of f of x, and then you have 2x over 2 left over. Well, what's going to happen with the 2's? They're going to simplify again. And so your g of f of x is equal to x. And so it doesn't matter which way you go about it, they both end up as your y equals x. They're both reflections about that particular line, okay? So let's do another example, and then that's kind of the idea of the inverse, okay, and finding the inverse. Alrighty, so let's take a look at these examples right here. So we'll start off nice and simple. Okay, so say I had f of x is equal to 2x, okay? Something simple like that. I want to figure out what the, I guess, the g of x or the inverse will be. And you know, I'm going to stop calling it g of x. I'm now going to start calling it the f to the negative 1 of x. Because this notation is how we actually describe the inverse, okay? So I'm going to start using that notation, okay? So we want to figure out what the inverse function of f of x would be. So remember, what we have to do is we have to change our y and our x around. So we now have x is equal to 2y. Now solve for the y. We're going to divide by 2 on both sides. And so now I have x over 2, because those are simplifying, is equal to y. And that's what my inverse is. I have my x over 2. Okay? Now, with that being said, we can verify that this is indeed the inverse by going ahead and saying f of the inverse, okay, of x inside the original function. And so we have ourselves 2, and then I have x over 2 plugged in. So the 2's are going to simplify, leaving me with this right here, that this function is equal to x. So these are indeed inverses, so this is what I'm looking for. I've got the original function and the inverse function, okay? Alrighty, now let's go ahead and take a look at another example. Alrighty, so let's try this one. Let's do f of x is equal to 1 over 3 x minus 2. And I want to figure out the inverse, okay? Now, what I'm going to do is I'm going to plug in my y, and then I'm going to switch them, right? So I have x is equal to 1 over 3 y minus 2. And so solve for y. So I'm going to go ahead and add 2. So I have x plus 2 is equal to 1 over 3y. And then I'm going to go ahead and multiply by 3 on both sides. And so now I've got 3x plus 2 is equal to y. Now, generally, they want you to sometimes distribute this in, and so you have 3x plus 6 is equal to y, because then that's now your mx plus b, right? And so that would be the inverse. Now, you can verify if that's the inverse by going ahead and doing this. You could say, and then I'll go ahead and create a little border for it. So this would be our 3x plus 6 up here. So I've got f of the inverse, right, of x. And that would be equal to, I've got my 1/3, and I've got 3x plus 6, and then minus 2, okay? So I'm going to distribute the 1/3 in. So by doing so, I've got myself a x, because 1/3 times 3, that's just 1, so that's x. What's a 1/3 times a 6? Well, that's a 2, so I've got plus 2, and then my minus 2. Well, what's 2 minus 2? That's going to be 0, so it's going to go, we're going to have y equals x once again. So we can determine that this up here is indeed my inverse, and this is the original function, okay? So that's how you would do those. Now, sometimes not every function you work with is a linear line, right? We've worked with other functions that have like a U shape or an S shape, so things like a quadratic or things like a cubic, even a root function now. So let's talk about how we would address those. So the first thing we have to understand is that there's this thing called the horizontal line test. And this horizontal line test is drawn after we figure out the inverse of a function. And if it crosses over it once, like it does right here, just one time, then it's okay. The inverse is a function. But if we do it over here, okay, the inverse is not a function, okay? So if it crosses twice. And this will make a little bit more sense later on, okay? But that's kind of the idea. Now, a lot of the examples we will be teaching you and working with you is not going to really abide by this one over here. They're really going to actually fit more the mold of this one, okay? Because we want you to go ahead and really see, how the original function becomes the inverse, okay? So let me get rid of this and let's look at some examples. So let's start off nice and easy, okay? Now, when we start talking about these functions that are no longer linear, we actually have to give them restrictions in order to figure out the inverse of them. So for instance, if I'm talking about the function y equals x squared, then what I'm looking at is a function that's not a linear line, but what I can go ahead and do is give it a restriction that would allow me to interact with it, because otherwise it's not going to abide by the horizontal line test. And so I'm now going to look at it where x is greater than or equal to 0, okay? So that's actually going to restrict what I typically draw, because the typical y equals x squared is this U shape. But if I'm only looking at where x is greater than or equal to 0, that means I'm only looking at it from the origin onward, which means I'm only going to be worried or concerned about this part of my graph. I'm not going to be concerned about what's in yellow over here, okay? I'm not going to be concerned about that. So now there might be some restrictions on these, and these inequalities are going to come into play. Now, what we first are going to go ahead and do is we're going to go ahead and say x is equal to y squared. We're going to flip it, right? Because we're trying to find the inverse, where my f of -1 of x, okay, what is that? So in order to get rid of a squared, right, we have to perform the square root. And so we take the square root on both sides. And so then you have the square root of x is equal to y. So the inverse function is f to the -1 of x is equal to the square root of x. Okay, so this is the inverse. Okay. Now, if the domain of f is restricted by the, x is greater than or equal to 0, then the inverse must also obey that, okay? It also has to abide by the same domain restriction. So the way that would end up looking for these two functions is you would have, I guess I'll do this one in red, and I'll do that highlighter thing. So this one would look like this, right? That's the U shape of it. Then we know how square roots look. The square root of x is going to look something like this. And if you were to go ahead and view the y equals x, this one would have this going through it. And so that is where we would get the reflection, okay? So, and also you would be able to, if you wanted to plug one inside the other, you'd get y is equal x, 2x, okay? So let's take a look at another example before I cut you loose and see how we're doing. Alrighty, so let's try this one. Let's do y is equal to 2x cubed plus 1, okay? And so now we're going to go ahead and try to figure out the inverse first, okay? And so I'm going to swap them. So I've got x is equal to 2y cubed plus 1. And then now let's go ahead and solve for y. So we're going to subtract 1 on both sides. So I've got x minus 1 is equal to 2y cubed. Now I'm going to divide by 2 on both sides. And so I've got x minus 1 over 2 is equal to y cubed. Now how do we get rid of a power of 3 or a cubic function? We do the cube root. So I'm going to do the cube root, okay? So I have the cube root of x minus 1 over 2 is equal to y, okay? And that right there is going to be my inverse function. So let me go ahead and do the cube root of x minus 1 over 2 right there. And so the idea is you'd be able to plug this one into the original, and you'd be able to get y is equal to x. Now, if you're kind of curious on how that happens, I can quickly show you. Y is equal to 2, and then we have the cube root of x minus 1 over 2. The whole thing is raised to the cube plus 1. So the cube root and the cube, those are going to go ahead and simplify out. And so then I've got y is equal to 2 times x minus 1 over 2 plus 1. 2's will simplify. And so then you end up with x minus 1 plus 1. And y equals 1. So it still works, just like a charm. Now let's do 2 more just so that way we're good to go. And here we go. Let's do this one. So I've got y is equal to 2 square root of x minus 3. Now that right there is going to be the original, so that's my f of x is equal to 2 square root of x minus 3. And then let's find the inverse. So the way we're going to do that is we're going to switch the x and y. So I've got x is equal to 2 square root of y minus 3. And so then I'm going to divide by 2 on both sides. So I've got x over 2 is equal to the square root of y minus 3. And now I'm going to square both sides, okay? So that's going to get rid of my square root and my squared. And now what I have here is I can distribute that using the powers rule, right? So I have x squared raised to the fourth, or not raised to the fourth, but x squared over 4. And then I have y minus 3. Now what I'm going to go ahead and do is I'm going to go ahead and subtract 3 or add 3 to the other side. So I've got x squared over 4 plus 3 is equal to y. And then voila, you're done. Now you could write it like this if you wanted to do 1/4 x squared plus 3. That is also okay. Totally works. And so that'll go right here. So you've got your 1/4 x squared plus 3. Now, the reason why I think we should do just one more is because you might run into a question like this, like maybe like on an SAT or something like that, or maybe in future math courses, where it might ask you, determine whether the functions are inverses of each other. And so let me show you one solid example of that, and then you'll be fine. So I went ahead and got that out of the way. So say I was asking the question and said, determine if f of x, that is 3x minus 1, is an inverse to the function g of x, which is the x plus 1 over 3, okay? So the way we would have to go ahead and do that is we would have to go ahead and plug them both, okay? We'd have to basically plug them into each other, right? To see if they would give us the reflection y equals x, right? So let me go ahead and do the first one. So I've got, and I'll do this in maybe a different color. So I've got f composed of my g of x. And so now that gives me 3, and I've got my x plus 1 over 3, and then minus 1. So the 3's will go away, and then I've got this right here, x plus 1 minus 1, and so these will simplify, and so I've got this is equal to x, okay? So since that is true, then yes, they are inverses of each other, but let's also just double check the other side, okay? See if it works for both. So say I did g and I put in my f of x, then that's going to give me x, no, not the x, but 3x minus 1 plus 1 over 3. So the minus 1 and the plus 1, those will add to 0, and then that gives me this right here, 3x over 3, and the 3's will simplify, and that gives you this. Alrighty, so as you can see, it doesn't matter which way you go about it, they both come out to y equals x. So we would say yes, f of x and g of x are inverses of each other. Alrighty guys, that's it for this video. Thank you for tuning in. Let me know if you have any questions on the homework or maybe with this video, okay? I hope you guys are doing good. Talk to you later. Bye.